function. First of all, we have to look at the domain. So this inequality means negative infinity to 1. This inequality means 1 to infinity. Because of that, I realize that the domain is all real numbers. So I can get the table started. In the table, I have to have everything I want except especially 0 and 1. 0 has to be in the table no matter what, because it will give us the y-intercept if there is one. And 1 in this case is the key x value because we'll have underneath a parenthesis facing left, this one, and a bracket facing right, touching. So on this interval, from negative infinity to 1, I will be using 4 minus x squared. And of course, on this interval, I will be using x plus 5. The left function is quadratic. The right function is linear. Just for a second, let's look at 4 minus x squared on the side. Just discuss it for a moment. Obviously, I know this function because the base function is x squared, right? Sorry, my marker smudged. And then negative will be this, and then up 4. So I know how to graph this function. 1, 2, 3, 4. It will look like this. However, I have to restrict it between negative infinity and 1. So I will be plugging in 2, obviously, y2, because these are the x and y intercepts, plus or minus 2, right here. So 2, when I plug in 2, what do I get? Very good. When I plug in 0, what do I get? Very good. I have to plug in 1, although if you remember, we should not, but we will leave it as an open point. So
one supposed to be negative 2?
Of course.
Okay.
Thank you very much. Of course. My apologies. So negative 2, indeed. I was talking about negative 2 and 2, but I didn't write negative 2. Sorry. Thank you. So, and then this is 3. On the other side, I plug in 1, and I get 6. I plug in 2, and I get 7. So negative 2, 0, 0, 4, and 1, 3. But it's an open point. And then 1, 6. So this is 4, 5, 6. And then 2, 7. Sorry for the lack of space. So now this is our piecewise defined function. And can anyone identify the range? Very good. To infinity. Excellent. Thank you. Very good. Any questions? No one had any questions from the test?
I looked over your sheet, so when I redid them, I seen the errors on the ways.
That's okay.
I just hope I remember them.
You did very well. Good. Next question. Amanda, is this okay?
Yeah.
Good. Anyone else? Any questions on this? Okay. Anything else you would like to pick from here? Yes. Which one?
Number 3. The difference of quotient.
Number 3? Yes. Very good. Very good pick. So we have f of x, which is negative 2x squared plus 7x minus 11. And we're asked to find the difference quotient, which is, as we know, f of x plus h minus f of x divided by h. It will be given to you. You don't have to memorize it in this class, as we mentioned a long time ago. Okay, which piece we have to work on, and which pieces we don't have to work on? There is nothing I can do to these two. They are just expressions. But this one I don't have. So I have to find f of x plus h. How do I find it? In the same way I find f of 3. It's the same way. What do I have to write? Very good, awesome. Very good. However, it requires work because I have to completely simplify it before I replace this with it. So what do I have to do first? What operation I perform first? Yes. So then f of x plus h equals -2, and then what do I get? Yes. Thank you very much. And now I can distribute. And I have -2x squared, -4xh minus 2h squared plus 7x plus 7h minus 11. Now I can go back to the difference quotient, and I have all pieces. All I have to do is just put them together and simplify and give the final answer. What has to happen every time I determine the difference quotient for any function? Two things must happen. What is the first one?
Something must go away.
Yes. All terms without h. All terms without h from the top must go away. Maybe some other terms will go away, and that's fine by me. But definitely all terms without h must go away. Then what is the second thing that has to happen? The
H goes out of the denominator.
The h in the denominator must go away. There may still be an h left in the problem, but the one in the denominator must go away. Okay, very good. Thank you. So I copy f of x plus h. I copy this, and then I distribute -1 to all three terms, and then divide by h. So -2x squared minus 4xh minus 2h squared plus 7x plus 7h minus 11 plus 2x squared minus 7x plus 11 over h. Is this okay? Is this okay, everyone? Yes? Now, as expected, the terms without h must go away and do go away. Otherwise, we have some error somewhere. And now I see there are three remaining terms. They all have to have h, so I can pull it out. And if I pull out h, what do we have left? -4x minus 2h plus 7. I simplify the h from the top with the h from the bottom, and I get this. And this is the final answer. Is this okay? Is this okay for everyone? Very good. So let's choose the next problem. Anything you want from anything.
Maybe number 1.
Yes, which one?
Number 1.
Which one from number 1? Or all of them? Or
All of them.
all of them. Very good. So let's take a look. 5 divided by x plus 3 plus 1 divided by x minus 2 equals 8 divided by x squared plus x minus 6. Bless you. This is definitely an equation. What type of equation is it?
Rational.
Excellent. It has a fraction. It has x in the denominator. It must be rational. Very good. Good, so I have 5 divided by x plus 3 plus 1 divided by x minus 2 minus 8 divided by, and I have to factor the denominator. How do I factor the denominator? Very good. X plus 3, x minus 2. I have to state 2 restrictions since I see 2 different factors in the denominator. And they are -3 and awesome. Thank you very much. And now I have to find the least common denominator. So let's find the least common denominator. Yes, and remember, if you forget to write the equal symbol and 0, you are changing the equation into an expression and you are not going to solve, right? So indeed, x plus 3, x minus 2. And remember, you cannot simply copy the numerators. You have to determine the adjustment needed. So what does the first top need? Exactly, it needs x minus 2 because it doesn't have it. And what does the other one need? Good. And what about the last one? You don't have to write anything on the last one. It's the same thing because it's the entire least common denominator. So can anyone dictate the numerator? 5x minus 10 indeed. Yes. Very good. Excellent. So remember this, at this stage, I simplify, and now this is a proportion. So I have 6x, and this is minus 15, I think, divided by x plus 3 times x minus 2 equals 0 over 1. And since it's a proportion, cross multiply indeed. And then 6x minus 15 will equal perfect. So then 6x equals 15, or x equals 15 divided by 6, and we simplify by 3. So x equals 5/2. Now my first concern is to make sure that this is not on this list. Is 5/2 on this list? I know it's silly. No. So assuming we had no mistakes, this should work. Do you have to go back and check? No. Should you? If you have time, yes. But it's not part of the solution. Like, for example, in solving radical equations. That checking is part of the solution. You must. Like logarithmic equations, if you don't state the common domain, it's part of the solution. You have to go back and check. Very good. Part B. 3x minus 1 squared equals 75. What type of equation is this? Yes, we have 4 different methods for quadratics, for quadratic equations. Which one applies here? Like this. It's already completed. It's already factored, taking square roots. This is set up for taking square roots. The simplest possible method right now is taking square roots. And I have 3x minus 1 on the left-hand side instead of the absolute value, actually. But I should not forget, since I'm not putting the absolute value on the left-hand side, I have to put something else that replaces it on the other, plus or minus. 75 is 3 times 25, so this is 5, the square root of 3. I move 1 and divide by, very good, 1 plus or minus 5, the square root of 3.
That can be done with quadratic formula, right?
But then you will have to expand, and you have to move 75. And it will take you another 5 minutes before you even start the quadratic formula. I'm not saying no. I'm saying it's something like this. That's why we study those 4 formulas. This is typical for taking square roots. You should not apply anything else. It's a waste of time. Will you get the answer? Of course. So this is typical for that. That's why it's there, to review that method. Now this is what type of equation? Ooh. Yes, indeed. It's a radical equation. Good. Awesome. What should I do first?
-5.
Exactly. Isolate the radical, in other words. Awesome. Isolate the radical. Next step.
Square both sides.
Indeed. Good. Great job. Left-hand side. Perfect. Very good. Very good. Do you remember when we first discussed this? Was 3.5 months ago. Did it pop up almost every class? Good. Quadratic, move terms around. X squared minus 11x plus 28 equals 0. I subtract x and I add 3. And now we are connected forever. We spent 3.5 months together. So
Okay, where did you get that?
I have to move x,
Right.
and I have to add 3.
Okay.
Yes, because that's how we solve quadratic equations, yes. And now,
You have to.
yes, if it takes too long to factor, only then use the quadratic formula. Or when it's not factorable, or if it's not set up like this. Good. Next step then.
X minus 7, X minus 4.
Excellent. So it appears that x equals 7 and x equals 4. And this is exactly what I mentioned a minute ago. It's part of the problem to go back and check. We have no choice. So 7 and 7. So 7 minus 3 is 4. The square root of 4 is 2. Is 2 plus 5 7?
Yes.
So I will say yes for 7. Now I'm checking 4. You know it's not going to work. How do I know? Because if this is 4 and this is a positive number plus 5, can I get 4?
No.
No. So let's check anyway. 4 minus 3 is 1. The square root of 1 is 1. Is 1 plus 5 4? No. Very good. Okay, the absolute value equation. I'm sorry. What type of equation is this? Sorry. Okay, if you remember, there are two options for this. Why? Because this number in here could be what? So that the absolute value is 2. What could this number be?
Positive and negative.
What?
Uh,
Okay, yes, of course. 2/3 x minus 6 is 2, or 2/3 x minus 6 is negative 2. Indeed. So then 2/3 x is equal to 8. I have to move 6 to the other side. And multiply both sides by 3/2. 3/2 and 3/2. The left-hand side is x, or 1x if you want. And when I simplify here, or you just say 3 times 8 is 24, divided by 2 is 12. Or this is what I would have done. I would have simplified by 2. Same thing here. I have 2/3 x equals 4. I'm adding 6 to both sides. And I want to get rid of 2/3. Multiplying both sides, indeed, of course, by 3/2. And I will simplify, and I get 6. So this absolute value equation has two solutions, 6 and 12. You can go back and check. It's not required. It's not part of the solution, but you can always go back and check. So this was number 1. Next problem that you would like to work on.
over 2?
Yes, of course. Never, please, never be afraid of fractions, though. Okay, so we have x divided by 6 plus 1 over 8 less than or equal to x over 2 minus 3/4. Okay, perfect. What type of inequality is this? What do you think? Is it absolute value?
No.
Radical? We didn't even look at radical inequality. It's not in this class. So what type is it? It would be rational if x were in the denominator. There is no x in the denominator. It's a linear inequality. Very good. Good. So I want to get rid of what? Yes. So I will multiply everything by
18.
no, because 18 is not divisible by 8. Exactly. The least common denominator is 24. So 24 divided by 6. Very good. 4x then. Plus 24 divided by 8. Very good. Less than or equal to 24 divided by 2. And 24 divided by 4.
6.
Times 3, 18. Easier? Yes.
I didn't understand how did you get you to 24.
Okay. 6 is 2 times 3. 8 is 2 to the third. This is 2, and this is 2 squared. So the least common denominator has to have all different factors we see here. I only see factor 2 and factor 3. I have to choose the highest power for 2. The higher power, this is 1, 3, 1, 2. I have to choose 3. I have to choose the highest power for 3, which is 1. And that's how we get 24. Better? Is it okay? It's exactly what we did with rational equations. That's exactly the same procedure. Except that we did not really have powers on those factors. And I was always asking you, how many different factors you see? And we normally had 2 different factors. So they were both power 1. It's the same procedure. It looks differently because this doesn't have x in it. So I will be moving 12 and moving 3. So negative 8x less than or equal to negative 21. And x is 21 over 8. But I need to, yes, because I divided both sides of the inequality by a negative number. So then x is in the interval 21 over 8 to infinity. Any questions? Any questions?
Can you do part C too?
Yes, of course.
I forgot how. Yeah, I just did.
And B. Okay, let's do B. Don't forget the final on Tuesday. Okay. B. Negative 3 less than or equal to 2x plus 5 divided by 3 less than 6. Good. This is a compound inequality. How do we address this?
Multiply both sides by 3.
Everything, all 3 sides by 3 indeed. So negative 9 less than or equal to 2x plus 5 less than 18. Subtract everything by 5, yes. So negative 14 less than or equal to 2x less than 13. Very good. Yes. And then we divide everything by 2, negative 7 less than or equal to x less than 13 halves. And this is the solution right here. Bracket negative 7, 13 halves, parenthesis, x in this interval.
When do we have to do like the U?
For the absolute value inequality.
Oh, so we'll do that for C.
Yes. Yes, indeed. Any questions here? Any questions? Okay, so let's move on to C. So we have 3x plus 2 in absolute value greater than or equal to 3. And before we finish our class today, before we adjourn, I would like to make sure that I add up your student opinion forms in here. So don't let me forget. Yes.
For D, that was an absolute value one. Did we not have to do that one? For number 1, part D.
Yes. So what was the question? That is an equation.
So you need it. Okay.
So there are only 2 possibilities. However, absolute value equations can have no solutions, infinitely many solutions, 1 solution or 2. But in this case, we only have 1 absolute value. So, okay, ready to look at this? Okay, which type is this? There are only 2 types of absolute value inequality. The type with the in between or the type with outside. Which one is it? Exactly. By outside it means that I have to write 2 inequalities, not in a chain, completely separate. And can anyone give us those 2 inequalities? And yes, the solution will have the union because it's the outside.
3x plus 2 is greater than or equal to 3, and then 3x plus 2 is less than or equal to negative 3.
Awesome. Exactly right. That's all we needed. And now we can solve these 2. So 3x greater than or equal to 1, or x greater than or equal to 1/3. And the other one is 3x less than or equal to negative 5, or x less than or equal to negative 5/3. And you know which one goes to the left and which one goes to the right from here. So how do I write the final? Yes? No, I cannot. I have to start from the negative infinity. I have to start with this one. So negative infinity to negative 5/3 in the bracket, and then bracket again, and this one, right? Is that clear? Okay, since I think everyone filled out the survey, correct? I'm pretty sure. Okay, I'm gonna add the points that I promised.
Those weren't added yet?
They're not added yet.
Yes, I got 83. I'm psyched.
No, they're not added yet. I'm adding them right this moment for everyone.
Yes.
And I have to subtract 10 points from Jeremy's grade.
Man.
Yes.
No, he deserves 115. Okay.
Just be proud of what you got. You're awesome, okay? That's it.
Okay, done. Thank you so much to all of you. Okay, I'm ready for next problem. What am I doing next? Number 5.
Yeah, let's just roll with it.
Yes, of course. It's just that we may not be able to finish. So I'm hoping that if you're not going to be here meet with me on Saturday, then you will at least look at the video, because we may not. We have about 40 minutes left. So we may not be able to finish. So in 1980, 21%. In 2010, 27%. The X represents number of years since 1980. What does 1980 represent?
0.
Very good. And percentage of students who are liberal is linear. Find the linear function that fits the data. And then find a year in which the percentage of college students who are liberal, assuming the model still holds, increases to 50%. So we are given some information. We are told that the relationship is linear, and we're asked to find the linear model and also answer an additional question.
Isn't that the A equals PE RT?
That is not a very good question. Very good question. When we are told the model is linear, we know it's not exponential.
Okay.
If we are told the model is exponential, then we have to think in terms of e to a power.
Okay.
Would it be x plus 21y equals?
So first of all, let's analyze what we're given. So
Oh,
when you hear linear, I say to you linear, what do you picture?
A line.
A line. How many points do I need for a line? So give me the points.
Oh.
0.1.
Exactly.
And 27.
So please find the slope. And tell me which of the two equations y equals mx plus b and y minus y1 equals m times x minus x1 you will be using. Both
So to get the slope is x2 minus.
rise over run, not run over rise.
Okay, so is it y2 minus y1?
Exactly. Change in y over change in x. Yes, 27 minus 21, 6 over. Very good. Or 1/5. Measurement unit, please. We must write the measurement unit. The measurement unit for 1/5 is a ratio of two measurement units. One coming from the top over the one coming from the bottom. So what is the measurement unit for this? What is the measurement unit of the top? Over. What is the measurement unit for the bottom?
Here.
That's it. So it appears that the number of college students who are liberal, blah, 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 increases by 1/5 or 0.2% per year, because it's positive. And now I have to analyze these two, see which of the two equations I'm going to use. Am I going to use y equals mx plus b or the other one? Perfect. Why? because I have b, which is 21. This is the y-intercept. That's why this is b. If I had 5, 21, I would have not been able to use this. I would have used this. But since this is 0, number, this is the y-intercept, and this is the point-slope form. This is the y-intercept form, slope-intercept form. So then 1/5 is here. So then the equation becomes y equals 1/5 x plus 21.
And then use 20-50% for FY.
Exactly. Awesome. Subtract 21, get 29, equals 1/5 x. And x is the number of years since 1980. If the model still holds, we will say that the percentage of liberal students out of the total will be 50%, assuming the model still holds.
So
145 years since 1980. So 5, 1, 2. If the model still holds. Good. Next question.
Number 6.
Okay, so is this graph of a function? Is this the graph of the function? By the, yes will not be good enough. I have to write yes. Yes, by the vertical line test. The graph does not extend to the sides. Find the domain and range. I think I put this problem on a previous discussion or not. Okay, so what is the domain? So obviously this appears to be 0, and this is 17.5, so this is 20. So the domain is 0 to 20. So domain is 0 to 20. What about the range? So if this is negative 4, 5, 6, 7, so negative 7 to positive 7. Find intervals of increasing, decreasing, and constant. Is this function ever constant? No. Is it increasing? Yes, it's increasing here and here, meaning from 0 to 5 and from 15 to 20. So f increasing on 0 to 5 union 15 to 20. Is this function decreasing?
Yes.
Between 5 and 15. It's right here. For x between 5 and 15. Very good. Find the x-intercepts, x and y-intercepts, and present the ordered pairs. So here's one, and here's the other. So the x-intercepts are 2 at 0 and 10. But what about the y-intercept?
what about the other X over there? Like, what about 20?
Yes, also. Thank you. I was thinking of the y-intercept. I thought. So the y-intercept is only this. The x-intercept, 3. So for the y-intercept, 0, 0, and x-intercept, 0, 0, 10, 0, 20, 0. Find the local or relative min-max. So there is a max here at 5, 7, and there is a min here at 15, negative 7. So I'll say max 5, 7, min 15, negative 7. Is this function symmetric?
Yes.
Symmetric means, first of all, if it's even, I have to see something on the negative side of the y-axis. So there is no such thing. There is nothing on the other side. And if it's odd, I have to see something across the origin, and there is none. So I will say none of the above. Find the x values when f of x is negative 5. For f of x equals negative 5, I have to draw this line, a horizontal line. Y equals negative 5. It crosses the graph into two different points. And I read the x values, 12.5, 17.5. 12.5, 17.5. And find f of 7.5. 7.5 is this. I draw a vertical line at 7.5. It crosses the graph in this point, and I will be reading 5. 5. Any questions on this? Okay, so 1 minus x over 2x plus 6 greater than 0. What type of inequality is this?
Rational.
Yes, it is rational. Is it